A non-native invasive insect, the balsam woolly adelgid, has caused extensive damage to North American true firs since its introduction in the early 1900s. Species like Fraser fir, a rare endemic native to the high elevation forests of the southern Appalachians, has seen large-scale mortality events attributable to this pest. However, not all species of fir are susceptible, and understanding the underlying resistance mechanisms enables better control and management of these pests in natural areas, as well as informs breeding programs which aim to produce resistant lines of trees. When a tree species is termed resistant, this resistance generally falls within three broad categories. Non-preference, where some aspect of the tree chemistry or morphology inhibits insect feeding activity. Antibiosis, where tree chemistry results in a biological impact to the species that feed on it. And tolerance, where insects' feeding activity does not result in significant damage to tree structure and function. We know from previous analyses that balsam woolly adelgid crawlers will insert and begin to feed on resistant species of fir. However, these infestations do not persist, suggesting the potential antibiotic effect of constitutive or baseline chemistries between resistant and susceptible species. Through the use of gas chromatography and mass spectrometry, much in the way a dog's nose smells the individual components of a mixture, we can separate and identify specific chemical constituents in different species of fir, evidenced as individual peaks on these chromatograms. And moreover, we can compare chemical differences between resistant and susceptible species. To this end, we had 3 arboreta across the country ship fir branch samples across the known resistance spectrum to the balsam woolly adelgid, where we then analyzed and compared constitutive chemistries to build a predictive model that aimed to utilize chemical differences to place species of fir within their appropriate resistance level. Moreover, identify specific chemical constituents more associated with resistance. Our predictive model was 95% successful at utilizing chemical differences to place each species of fir within its appropriate resistance level, indicating the potential role that these chemical differences may play at conferring resistance to certain species of fir over others. And moreover, we are able to identify specific chemical compounds, such as alpha-pinene and caryophyllene, more associated with resistance, that we can then test experimentally on different stages of the balsam woolly adelgid life cycle to ascertain any and all effects, thus potentially unlocking a resistance mechanism that has eluded scientists for years. Thank you.